Hello, greetings, and I hope you are safe and well. My article topic is intelligent model to carry out an adequate smart grid with the ecological footprint, agile to implement, optimal for energy demand predictions, and ideal for electrical vehicles in a smart city. Presented by Shaba Musavi Qasiblu. Outline of the article, title presenter information, introduction, then methodology, possible results, and in the end, reference. Part of introduction. In this slide, I am trying to introduce about a smart grid, and a smart grid is one of the most important aspects of the smart city. This grid provides an intelligent connection between users, the power grid, and energy suppliers. However, increasing energy demand has also increased greenhouse gas emission and contributed to climate change. A smart grid is an electrical grid which includes a variety of operation and energy measures, including advanced metering infrastructure, load control switches, and smart appliances. Renewable energy resource, including the capacity to charge parked electric vehicles, energy efficient resource, significant utilize grid fiber operator to connect and monitor, and extra. So, in this slide, as we can see, the trend and number of documentation produced about the smart grid between 21 to 2021 in thousand. So it's clear that our research would like to work on this topic. And its topic is so much hot topic in the world. In this slide, I introduce some key points about the smart grid required for electric vehicles in a smart city, and thermal power plant, solar power, wind power plant, and industrial plant, electro vehicles, cities and offices we can use in smart city and smart grid. Problem statement. The size of smart grid required to support 10,000 electrical vehicles in the smart city will depend on several factors, such as population density, number of charging stations, energy storage capacity, and the use of renewable energy in the grid. Generally, a smart grid with the capacity to handle a lot of the less 10 megawatt will be depending to charge 10,000 electrical vehicles. However, this figure may vary depending on the specific characteristics of the smart city. So, charging capacity, energy storage, demand management, remote monitoring and control, use of renewable energy. So, to support 10,000 electric vehicles in a smart city, the smart grid must have the capacity to charge enough electric vehicles, store energy, manage demand, remotely monitor and control the grid, and encourage the use of renewable energy. The size and specific features will depend on the needs and of the smart city in question. In this slide, we can see cost of electric vehicles based on their increases in a planning horizon from 2023 to 2037 and that specific the increase in energy demand based on the changing hours of use in a smart city. Research objective. The general goal of the current study is to ensure a transparent, sustainable and environmental friendly system operation that is cost and energy efficient, secure and safe. Objectives and developing the smart grid are quite different from country to country for their various demands and start points. In this slide, a smart grid employs innovative produce and service together with intelligent monitoring, control, communication, and self-healing technologies in order to maintain and improve the existing service efficiently, allow consumers to play a part in optimizing the operation of the system, and extra. Justification. The need to electrify transportation to driving by diverting oil supplies and growing environmental concerns and technology advancement has accelerated the introduction of electric vehicles to the market. However, the stakeholders in the electricity and transportation sector, such as electricity produce, power grid operation, and extra, and the electric vehicles load many increase power cost and change the generation profiles of the produce, increasing dioxide carbon emission, and high penetration and infrastructure charging also jeopardize the variability of distribution network. For instance, if the charging load can be moved to less busy time, duration reduced to 5% and only about 30% of network infrastructure would need to be improved for a 25% electric vehicles penetration. Scope and delimitation. Creation of a challenge for infrastructure development of the charging station. The studies that have already been done on developing charging infrastructure show that the issue has many different behaviors, and solar photovoltaic based electric vehicles feasibility studies before electric vehicle developments. Numerous infrastructure such as charging stations are needed to meet the rapidly growing demand for electric vehicles. Some reference in this slide, as you can see, I'm writing some reference that I use in this article, and in the end, thank you so much for your listening, and I'm waiting for any question and your comment. Thank you so much.